I just went out and came. Yeah, got late.
Not
So
an issue,
Tanvi
not an
joining
issue.
there?
Tanmay, he is returning from Coorg, I guess. So I don't think
Ah,
he will be joining now. So he has told us to just start the session.
okay, okay, sure, sure. Okay. Uh, okay, just to give me one more minute. I'll just switch on one more computer and come. Okay.
Sure, sure.
Sure.
Okay. Yeah, I'm back. Okay, so last week's discussion, from that last week's discussion, any questions, anything, anything you guys tried?
From last week, we had a discussion regarding the difference between Docker and virtual machine, like
Right, right.
how, yes, how the containers behave and how actually is different between both of things, right?
Yeah,
And after that, you told us to do some installations.
yeah, right.
You told us to try VirtualBox and install this one, Ubuntu.
Correct, correct.
So I had done that, and at the same time, for Docker, I think it was initially built for Linux system only, right? The containers,
Yes, yes.
mostly they were built for this one. So Tanmay has also joined.
Okay.
So what I'm saying is, hi Tanmay, hope he is audible.
Hi sir,
Uh,
I will be audible. Yeah.
Hey, hi,
so
Tanmay.
Hi, hi, Pavan.
Yeah,
So what I saw is Docker containers were basically initially built for Linux systems only. So, but
right.
because the containers use the kernel of the existing operating system, so
Right.
maybe the Linux-based things will not work on Windows. That's why you told us that we have to install the Ubuntu desktop, right? The Docker desktop, sorry. So I did the installation of Docker desktop also because I
Uh,
saw there you were writing some commands in WSL, I guess. Was it WSL or you were using a Mac operating system, I guess?
right. Mine is a Mac operating system. What is WSL?
Windows subsystem for Linux because while I was
Ah,
installing Docker, it was asking me to install this thing,
ah, ah,
WSL, because
ah.
otherwise it will not be working.
Right, right. Yes, yes. Yeah.
So all the command line, and for that, if you want the GUI, then we got this one, Docker Desktop.
Yeah, yeah. Okay. So you installed Windows subsystem for Linux, or I mean, is it like a virtual box? Because I have not tried it on
No, what
the.
I did is first I installed this one, VirtualBox.
Ah, okay.
After that, using that, I installed Ubuntu 23.10, the latest one.
Ah, okay,
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 and after
okay.
that, I made some research in YouTube, and actually, the resolution of the screen was very less.
Ah, ah, ah.
If I show you, can I share my screen and show
Yeah.
you?
Yes, yes, yes.
Okay, so let me just share my entire screen, and I hope my screen is visible now.
It's just getting. Yeah, yeah.
Yeah,
Now it's
okay.
visible.
So this is my VirtualBox software,
Okay.
and here you can see I have two. Actually, I made a YouTube video also for that. So I
Okay,
had
okay.
two virtual machines here.
Ah,
Both are
ah, ah.
powered off. So let me just start one of them and show you.
Okay.
So initially there was a problem with the resolution. The size was very small. So again I
Ah,
had to
ah, ah.
refer two, three videos and I got the solution. Now it is at least not full screen. At least it looks really good actually. We can use Linux in our Windows operating system only. It's really cool. I really liked
Yeah.
it.
Okay, okay.
And this is how it starts.
Yeah. So you're saying it is not becoming the resolution is not coming fully, right? Yeah.
After that I figured it out and now it is okay. Just let it start and I will show you.
Okay, okay. So
And
did you install Docker on this machine?
on this Linux machine I did not. I did it in my Windows only.
Oh, okay, 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 okay. You don't need to do it on Windows because for that you installed WSL then, right?
Yes, yes, exactly. Because
Okay,
when I
okay.
was doing in Windows, then I had to use WSL.
Yes, yes, yes.
So
No,
actually,
no.
I was trying to get the difference because we will be making lots of videos on these things, right?
Oh, okay,
So
okay,
you can
got it,
see here,
got it.
right? Now I'm having the Linux system in my.
Yeah, yes, yes,
So
yes.
here I have my Windows machine, and on top of that, you can see this is my
Yeah,
Linux
yeah, yes,
subsystem. So
yes, yes.
automatically I can use both of them also. And it is
Oh,
really very lightweight and very fast also, like
oh, it,
efficient
it
also.
is, yes, yeah, correct. It is fast actually.
Mm.
So, okay, one more thing is that, yeah, whatever you were saying, right? This Docker was first created for Linux. Why that is because this container concept was not new. Okay, that started somewhere around 1960, 1970s only.
Haha.
There was something called the LXCs. Okay, Linux container something like that. It was there LXC. So
Because of
that
that, I had to install this thing actually.
yeah, okay. So those were the first container concepts. It
Okay.
was started, and at that time, right, the machines were not too fast, so that nobody wanted to use that LXCs. Okay, because if you create multiple LXCs, machine was not that really powerful to make use of it.
Okay. Okay.
So now, actually, since machines are powerful, right, these containers, and Docker as a company, right, it created a very nice wrapper on this LXC. It created a very useful command line and a lot of features it provided, right? So
Yes. Yes.
that's how
Yes.
these containers became famous, actually. Okay.
Uh,
So yeah, so here once you are in the Ubuntu, right, you can easily install this Docker engine, Docker desktop actually.
hmm.
So that will come with the Docker engine, Docker server, Docker clients and all.
You
So
can
then,
see this one, right? The Docker desktop here.
okay, you
So
are all
because I had to install this in Windows, so I had to install that Windows subsystem for Linux actually.
correct, correct. Yeah, yeah.
Uh,
Yes, Windows directly doesn't support
uh,
containers, right?
okay, but in my virtual machine, I can do it, right? Directly in
Yes,
my
you
Linux
can.
operating system. Okay.
Yeah, yes, directly. It's just like a suit yum update
Uh,
or in this APK install Docker engine, Docker, I think.
uh, uh,
So you can try that actually. That you will find it in Google very easily. Okay.
sure, sure, sure. Yeah,
So
some Linux commands are a little bit tricky, but we have to get used to it actually.
yeah, yeah, I can help you there, no problem. So yeah,
Definitely, definitely.
once you start using the Linux, right, you will actually get used to it.
Actually, I was trying to figure out some Linux commands because they are really interesting also.
Yeah, yes. So, and once you start using this Docker on Linux, right, you really don't feel like using it on Windows. So, yeah,
Exactly.
it's nice actually there.
No, no, the thing is actually when we go to colleges and maybe most of the users use the Windows operating system only, right?
Yeah,
So
yeah,
I just
yes.
wanted to see the difference. Now next time I will do it on the Windows subsystem only, actually Linux subsystem actually.
Okay, okay, okay. I guess Windows also is supporting now containers. I think so. There are developments, okay, but I'm not aware of what exactly they are supporting and all. That
Uh-huh.
also we can investigate as we
Exactly,
go
exactly.
further.
Uh,
Yeah. So okay. So anything on any questions on the last time's last class contents?
no, no, like basically now we got the idea regarding what is virtual machine and what is actually the Docker.
Okay.
So at
Okay.
least a basic idea we have about that. Now we can, I think we can go on with the next thing.
Okay. Yeah. But by the way, I forgot to send all the details, right? So maybe this so some PPTs and all. I
Yeah, you
forgot.
That's
can send
okay.
everything
That's
in the this one now in WhatsApp group only. No, we will just look
Ah.
into that.
Okay.
And at the same time, even we want to create some of our own because then actually we'll learn more about the same thing.
Sure. Sure. Okay. Okay. Fine. Fine.
Just for
Yeah.
reference, you can give us some documents also, no problem at all.
Sure. Sure. Yeah. Yeah. I'll try to send it. Okay. This time.
Definitely.
Uh, yeah. So today, okay. From last class, we understood this VM and Docker, all those things, right?
Uh,
So today, I thought I'll give a brief, like how these containers will be useful in the production or in the cloud. Okay.
hmm,
Then after that, we'll go into this Docker building, image building. Okay.
okay.
So okay, let me share my screen. Just Okay, you can see my screen, right?
Yes, yes.
Okay. How do I? Okay, I'm also new with this. I don't know how do I delete this. No. Okay. Uh, we learned about Dockers and VMs last class. So now, how these Dockers are really helping us in the deployment or in the production. Actually, we know that Dockers are very fast. Dockers are like very lightweight. All those things. So we also understood that instead of creating a VM image, you can just can create a Docker image or a container image and pass it on to the others, right? We also saw the registries, right? So you remember the registry, how we like a developer creates the container image
Yeah.
and he uploads it to the registry,
Mhm.
and QA can download it and start using it for the testing purposes. Okay, so that we saw, right? So now, okay, yeah, it is here actually. So yeah, this is a registry. You can have multiple registries as well. Okay, so yeah, I'm still learning with these things. Okay, so yeah, okay, so now, uh, uh, how do we use these Dockers containers in the production? So I'll just give a brief idea. So do you guys are you guys aware of these microservices?
A little bit, not so
Okay.
much.
Okay, fine. No
No,
problem.
no.
Yeah. See, there's a concept called microservices, okay, which started in the recent times, mainly after this containers came into the picture, mainly after this Docker came into the picture. So previously, how do you develop a, product? Let's say we are developing an web application. Okay, it will have the database, it will have the multiple services. Okay, like a front end service which handles the maybe API handler,
Mhm.
uh, and which handles all the incoming requests. So then there will some middleware will be there, uh, and maybe there might be one or two more services, and then there will be a database handling uh, service, and then there will be a database, right?
Exactly.
Yeah, so it will be of this kind. Okay, so every module, even though they are separating it like module, they are creating, let's say they are creating module only, but everything is packed into one big piece of code, right? Kind of more of a coupled actually. This API handler will communicate to middleware. Middleware might be communicating to other services, and then also to the database handler, and maybe one more service here. So they talk to each other, but they are all on a single system, right?
Yes.
Yeah, so this is called monolithic architecture. Okay,
Architecture.
this
Okay.
is called monolithic architecture. So everything is in single one, that is mono. So everything will run on the same system. Okay.
Can you please repeat it? Like monolith services means that so many services are working in one single particular architecture or
Yeah,
computer, is it?
yeah, yes, correct. So even what why I said services is that to make you clear. Okay, so even if it is separately modularized, still they run together in a single system, right? You have the distributed systems also, but still most of the things will be on the same system. Okay, so okay, let's take an example of this application, only web application. So in this one, API handler will be there. Okay, first whatever the incoming user request, right, that will be coming here. That will handle the APIs. Then it will send it to middleware, maybe, or to the direct service one. Okay, maybe to the service one directly. So and these services will contact to the database, and which in turn contacts to the database. So the database handler, then which in turn contacts to the database. Okay, so this is a single piece of code. You can't run this one separately. For example, you can't run API handler separately. Okay, so to API handler to be there, you should also start the
Middleware
middleware.
also.
Yeah,
Yes.
so everything will you will start as like as a single application. Okay, so maybe you just run like app one, you just say app one dot sh or something. It will start
Okay.
everything together. Okay, got it right.
Yeah, yeah.
Okay, maybe you are writing an application. Okay, you are writing this application. How do you write it? You start coding every piece of code in your machine, and you will run it in your machine. All right.
Exactly. We will do it in
Yes,
our
yes,
local machine,
exactly.
then we
Yeah.
will maybe deploy it into the server.
Yeah.
Server. Yeah.
Right. So there are multiple problems with this one. Okay. So when code becomes too big, I mean when you start adding new features, right? The code becomes too big, and there will be a maintenance problem with this. Uh, like uh,
Mm.
uh, like most of the services or most of the modules, right? They will be mostly coupled with each other, coupled in the
Dependent.
sense of, yeah, more, they will be dependent with each other. So you make any changes to S2, your S3 will break. Okay, so like that, you make any changes to with your middleware, maybe S1 or S2 might break. So those problems, right? Those problems people started
So
encountering.
technically, this can be a tightly coupled architecture where everything is dependent on each other, right?
Yes, yes.
Okay.
Monolithic
Uh-huh.
architecture are mostly like a tightly coupled
Tightly coupled.
architectures.
Okay.
Yes. Yeah. So then you deployed this one on the production, okay, on a machine. So maybe at the starting you are just getting some thousand requests per minute or maybe something like that. So it was okay. One machine handling all the requests works fine for thousand requests. Maybe even if it increases to 10,000, you can just increase the CPU of this machine or you deploy it in another machine. It will work fine. But when it starts more and more, okay, more and more requests coming in, then you can't actually increase the CPUs to too much, right? You might have already increased the CPUs to maybe 100 GB,
Uh,
right?
so you were
So
talking about the scalability here, right?
yes.
Yes.
So scalability is a problem here now,
Hmm.
right? You don't have a machine which is more than, I mean, you get a bare metals of like 3000 GBs also, but it becomes costly actually. Okay, maybe today you are getting this many requests, but tomorrow suddenly your request might be like only 1000. It's
Uh-huh.
like Amazon. Okay, you deployed this product. You deployed this Amazon. What is that? Like Flipkart and Amazon is there, right? So you deployed your product. Okay, so one day only few customers will buy your product, but on the big billion days and all, like hell lot of
Uh,
customers come and contact your server, right? So if you have only like 100 GB, it may not work actually. So you might have to increase on that particular days, but other days you don't need that much of resources, right? So you just need one simple server to handle, one simple normal usual server to handle 1000 requests, right? So you will be, if you keep like 1000 GB of RAM and all, it will be just a waste of this one.
so it is not that flexible and like it is
It's
very
not
difficult to
flexible.
maintain that. Okay.
Correct. One is that code becomes too large and very difficult to maintain, and updating, enhancing a feature becomes difficult, right? And then second thing is the scalability. Okay, is a problem, right?
So like if there is any change, we have to again redeploy the same thing to the server, I guess.
Correct. Yes.
Uh,
Yes, that is one more problem. Yes, that exactly correct. So you, let's say that you are making changes to this middleware. Okay. Now you want to update this. You want to you had some hot fix or something.
hmm.
So you have to update this. Okay. So how do you do that? You have to bring this whole system down.
Exactly,
Okay.
exactly.
Whole system down. You can't only bring the middleware down because these things are dependent. S S1
Other
S.
things will not be working, right?
Yes, other
Uh,
things will be. come down. If you only try to, you will not even have an option to bring this only middleware down. You
Exactly,
have to bring
exactly.
everything down, and you again deploy the new thing. Okay.
Uh,
And maybe previously it was running version 1.0. You might want to run now 1.2. So when you deploy the 1.2, you have to bring this down, and that is a downtime, right?
exactly.
And then, like, you deployed 1.2, but there are some problems now. Suddenly you saw that in development it was working, but in production it is not working, right? So you again have to revert back to 1.0. Right.
Okay,
So how do
yes.
you do that? Again, you need to stop it. Again, you need to install 1.0, and you need to bring it up. Yeah. So that is down. So much of downtime will be there. Maybe like a few hours of downtime will be there. Let's say you have this. There are usually it will be like you'll run multiple instances, and there will be a load balancer. Okay, when the request comes in here, usually it will go to multiple this one. So let's say you are upgrading this one, still your request will go here and here, okay. But if there are too many requests at that time, some requests might fail, because only these two gets too much of request, means their performance also will drop down, right? So you might see some slowness in your website. You might see some kind of glitches in website. Those problems will come in, and response time will be reduced, right? When these things are only two things are there handling so many requests. So you understood, right?
Exactly. Yes.
Yeah. So even though you have a load balancer here, you still see the problems, okay.
Mm.
So yeah, these are the problems. So now how does this containers or microservices solve this problem? Okay.
So, are you talking like all this parameters will be individual there?
Yes. So that's the idea. Okay.
Uh-huh.
So what happens in microservices is that you will have, let's say you have this API handler.
Uh-huh.
This is a completely different service. Okay. This is completely a different service, and this uh,
Middleware is a different service.
middleware is a different is happening. Okay, something. Yeah, middleware will be a complete different service. Okay, so these two will talk to each other. These two will talk to each other using some protocols. Maybe in this case, let's say that they are using this http protocol.
Uh,
Okay, they can talk through http protocol, or
uh-huh.
there are few other things like they can even use the Kafka also to send the messages. All the so many things are there. Rabbit MQ services, a Zookeeper. So many things are there. Okay, I'm not fully aware of that, but I know this Kafka, and or even in a simple terms, you can use HTTP protocol. Okay, so application server or middleware server can run its own listener here. Listener in the sense HTTP listener. So application handler can connect to the middleware at that port, and they can send the do the get post put requests. So you guys know little bit about HTTP, right?
Yes, yes. So ultimately they are API requests only, right?
Correct.
API.
Yes, they are API requests only. They'll send the request and send the responses and
Yeah, I
all.
have basic idea about the five method: get, post, put, patch, and delete. That's all the
Yeah,
five I know.
yeah, yes, yes, correct. So yeah, they can talk between each other, like let's say yes one, yes two, right? They can talk to each other, and also like DB of, okay, they can talk to it, DB handler. Okay, so they can talk to each other. So now, since they, now what happens is that you can bring down s2 anytime. Okay.
Because they are all independent of each other.
Yeah, you can bring down s2 anytime, and you can bring it up anytime, because they are independent.
Mm.
So let's say But if you have only one instance of S1, hello,
Yeah,
hello,
yeah, I can hear you now.
hello.
Hello.
It was gone in between, an
Yeah,
internet
yeah,
issue problem.
yeah, yeah. I guess so. Some issue with my system. Okay, sorry for that. So you guys can you hear me,
Yeah,
right?
now it's audible.
Yeah. We can.
Okay, I think you might find this issue now and then. Okay, I am facing it from last 1 week. Yeah, it's fine right now.
Now it's okay.
Ah, okay. So, okay, now what I was saying is that when you can bring down S1 anytime, but you only one instance of S1 is there, then still it is a problem. Okay, so the middleware wants to contact S1, S1 is not there, then it has to wait until the S1 comes back. So, okay, so you got it right.
Exactly. Yeah, I got it.
Okay, so now
Uh,
what we can do is that instead of having only one S1, you can run multiple S1s. Okay, you can run multiple S1s so that let's say you want to upgrade S1 to version 1.0 to 1.2 now. Wait, okay. There. Hello.
yeah. It went again in between.
Yeah, it is going again. I'm not sure. Okay, 1 second. Mm, I thought it's only happening with Zoom. Now it is happening with Google Meet also. Yeah, it is not good actually. There's some issue with the network. Too much of latency is there.
Uh,
Yeah, it should be around 27 or 30 max. I guess we might hit into some problems till. Yeah, but I don't have any other option. Let's continue.
it's yeah. Let's continue.
Okay. So if you guys are not able to hear me, just ping me in this WhatsApp. Okay, I'll just see.
Sure, sure.
Okay, so instead of one S1 service, right, you can have multiple S1 service. So now, if you want to bring this from one dot, upgrade this S1 from 1.0 to 1.2, right? What you can do is that you don't need to bring all the S1 down. You can only bring one S1 down, and when you bring only one S1 down, this middleware can talk to other S1s.
So,
Okay.
so are they just one instance?
No, these are containers.
Containers. Okay, okay. Uh-huh.
Oh, you can think now as one instances also, no problem.
Uh-huh.
Okay. So, but usually in microservices, everything will be containerized.
Okay.
Okay. So when you bring down this S1, you can have traffic will go to other containers,
So
and
they
you
are the images of the same thing, but
same thing. Yes,
okay, okay,
correct.
okay.
Exactly same thing.
Uh-huh.
And let's say that you only two things cannot handle the request. You need three things. You
Mhm.
can immediately bring up one more container here. Okay. Container starting is like that containers can be started
Within
within like
seconds.
within seconds, like nanoseconds, right? So you
Uh-huh.
can immediately bring up one container. It will start handling the requests. You can bring the S1 down. You can upgrade it to 1.0, 1.2, and you can bring back the S1 up. So now S1 will be first container of S1 will be 1.2, but other containers will be 1.0. So 111 you can bring down and you can upgrade it, right? Finally, you can delete the extra one and you will have three containers. Okay,
Okay. Got it, got it.
got it, right?
Yeah.
You can ask me if any questions. Okay, we can stop and uh, uh, discuss.
Yeah. So
Any doubt?
ultimately they are very lightweight, so it is that's why it is very fast, right?
Yes, that's why it is very fast.
Uh-huh.
And now, since these things are all completely independent, you can deploy these things in a different systems, I mean instances. Okay,
Uh-huh.
so here what happens is that everything should be on the same instance, and your instance should be very capable. Like you should have like lots of memory, lots of CPU and all. But these things are like small microservices, means micro. Okay,
Very
or
small.
you
Okay.
create this micro services. Okay,
Mm.
small services. Like how do you create a service? A service should have only one functionality. Okay, you don't try to add multiple functionality to into one service. Okay, so this is a database handler, means that this part is a database handler, means it is only going to handle the database things, database communication to the database. Okay, you got it right. Any other computation, you will create one more service. Let's say you
Mm.
contact this database, you get some data. This database handler will only get the data. You don't do any computation of that data. If you have any if you need any computational, you will create one more service. Okay, maybe database data handler, or data computer, something like that. Okay, you can add one more service. So all your services will be like micro sized. Okay, so they are microservices. Okay, so now these services, right? You can put it in this, let's say this API handler service, middleware service. They are all light services now. So you can run these services on any normal computer. Okay, any normal system. Okay, even these services will be so light that you can run it on your laptop kind of systems also. Okay, got it right.
Yes.
Yes. Mm.
Yeah. So you one big code you broken into multiple pieces now. Okay. So now you put it in normal systems. Okay. So API handler you put it here, and one more API handler you put it here. Okay. Then one more container of middleware you put it here. Let's say you have three nodes, three instances. You put one more, like you deploy your applications, okay, on these computers. So yes, one,
It
yes,
went again. It went again.
yeah. You guys can hear me, means just replying. Okay.
Yeah, now it's audible.
Yeah, no, huh?
Okay. So yeah, I think it's some system issues is what I'm thinking. I don't know. Yeah, something is
No, actually, it
causing
might
some
be
trouble.
maybe network issue only.
Yeah, network issue only, and I guess this what is this meeting? Google Meet is actually hanging at that time, probably. Well, let me close few of the things. Okay. Okay. One more thing, I just wanted to send this. Let me send it to you now. Let's discuss about it later. Okay. So this is fine, right? So you guys are able to understand, right?
Yes, yes, yes.
Yes, yes,
This part
yes.
we understood.
Okay. Okay, so you deploy this microservices on multiple normal nodes. Okay, so this one machine might be so costly that you can buy some 10 machines like this,
Uh-huh.
small normal machines. Okay, so you can deploy these things on your and these wait, okay. Hello.
Yes.
Yes, yes, now it is
Okay.
audible.
Sorry. Yeah, I just connected to my mobile network. Okay.
Okay, fine.
Yeah. So let me try with this actually. Some issue with that my broadband, I guess. So let me try with this. Let's see. Okay. Sorry for that multiple
No problem, no
breaks.
problem. It happens to us also many times. It's okay.
Yeah. So okay, so you can have low-end machines and you can deploy your microservices on multiple, I mean, machines, and these things will communicate with each other with their defined protocols, maybe HTTP, or you can talk with the Kafka, all these things. Okay, so now if you want to, let's say you want S1 is there, S1 is not enough. Okay, so what you will do? I mean, one S1, one instance of S1 is not able to handle more
Okay.
requests. Okay,
Excuse me,
okay,
Pavan.
let's take an example.
Are you sharing your screen?
Oh yeah, yeah. Sorry,
Okay.
sorry, sorry.
Okay.
Oh yeah, yeah, yeah. Thanks for that. Okay, so now uh, now let's say 1,000 request comes. Okay, and API handler handles it fine. Only one API handler is required, no problem there. uh, uh, and once the API handler handles it, it will give it to the S1. Okay, now you have only one S1 for now. Okay, you are fine with 1,000 requests. Now your request becomes too much, too heavy. Then your API handler also cannot handle this one. So what you will do is that you will run one more API handler here. Okay, anywhere, any node. Okay, so these requests will automatically go to this API handlers. It will get load balanced between these, what, how many of API handlers are you are running, right? It will get load balanced between those, and these multiple API handlers can handle these many requests. Okay, now API handlers are handling these many requests fine, but S1, all the API handlers starts sending the processed request to the S1. S1 service is only having one pod. That is not enough. Okay, so you automatically can add one more S1 here. Okay, you are getting it right.
Yeah, that is the benefit of using microservices.
Yes, that is a benefit of using microservices, and all these things, whatever I said, right? All these things, no manual intervention is required. All these things can be automated using the Kubernetes. Okay, so
okay.
that I will come back, but just now I am only explaining you why what is the importance of these containers or microservices. Okay,
Mhm.
so so you just increase. Okay, you want to only increase S1 part now. API handlers are able to process this request, this main request, but S1 two S1 is not enough still. You just increase it to one more. Okay, you don't need to increase it there only. You can increase it in another node or anywhere. Okay, so now there are four instances of S1, so it can easily handle it. So now the request again reduced to 1,000. Okay, you don't need like four S1s. So then automatically you can remove these S1s. Only S1, only one S1 is enough. So what is happening is that you don't need so many resources. Okay, you don't need so big resources. Then if you are, let's say you removed S1 from here, now you don't need this full node at all because nothing else is
Mhm.
using this one. So you can just remove it off from the from your Kubernetes cluster, right? You can just remove it off. So there also you saved your charges, right?
Okay.
Yeah, so you can, and other thing is that you don't need to run the same same S1 on one instance. You can run different containers. Like you can run S2 on the same container, S1, S2, S3, DB handler, all these things you can run actually on the
Because they are
same
all independent, right? So they will not
because
be
yeah, they will
affecting
not be
each other.
interfere. yeah, they'll not be affecting the others, they'll not be interfering with the other services, right? So you can run any kind of container on any machine. Okay. And all these machines are like lightweights actually. If you
Uh-huh.
want more and more scaling, you keep on adding same small machines,
Uh-huh.
okay, into the cluster. This is called cluster in Kubernetes, so you can keep adding. And also this, as I said, upgrades, rollbacks, all those things are very easy with the containers, very easy with this Kubernetes.
Uh-huh.
Everything is automated, okay.
Okay.
Okay, these things we can discuss again also. Okay, when we come to the Kubernetes, we will discuss again. But I just wanted to give you the idea so that you will know like why why and where we are using this containers. Okay. So now let's say that you might have a question like instead of containers, can we not use the VM? Right, you might have a question. So you may not be able to use the VM so effectively. Why? Because see, I told you that we are using a normal machine here. Okay. Normal machine of my maybe i3 or i5 or i7 whatever. So with maybe 10 GB RAM or 20 GB RAM. Okay. So if you are running 2 3 VMs on the same machine, it will take lot of space. Images size is more. And it will, you need to define the exact size of the memory to the virtual machine, exact size of the CPU to the virtual machine. So it is not flexible. So you need more and more resources to run the VMs. Okay. and
Mm.
and one more thing is that VM size is so much, the booting time will take some time actually. Let's say,
Uh-huh.
okay, suddenly you are running only one API handler here. Okay, one API handler, something happened to this API handler, there was a bug in the code and it crashed. Okay.
Yes.
It crashed. So now what happens if you are using the container? Immediately within a second, one more API handler will be popped up automatically. Okay, because starting time for the container is very small. Okay,
Yeah.
it comes up in
Mm.
milliseconds. Immediately, without even manual intervention, Kubernetes will create one more API handler pod, and immediately all these requests will be passed to the other newly created API handler. Okay, so there is no glitch. Okay, or there is no disconnectivity for the user. But in case of VM, if you are using a VM, if this was a VM, so VM crashed, API handler VM crashed. Then if you want to bring up one more API handler VM, it will take like 5 minutes, right?
Yeah. Minimum 2 minutes it will take. Yes, exactly.
Yeah, that's what. It's like a too huge time. So
Uh,
yeah, and also you may not be able to run these VMs on lighter machines, less resourced machines. Okay, so that is one more problem. And there are other problems as well actually with the VMs. Like I said, you have
Mm.
to hard define what is the CPU for this VM. You have to hard define what is the memory assigned for this VM. They are not flexible actually.
but the
That again,
Docker images will be using the same operating system kernel for all the containers, right? So if you have multiple
yes,
containers also, we don't have to worry about the size given to each one of them. Like they
correct,
can
correct,
use
yes,
share the resources, I mean to say.
So basically,
yes,
it takes very less resources as compared to VM.
yes, yeah.
Okay.
Yeah. Okay. These things you understood, right? What I am, whatever I am saying. Because if you don't understand, just
Yeah.
ask me. Okay. So, uh,
No, there is one more term,
yeah, this
like
is.
a snapshot. A snapshot is like an
Uh-huh.
image of the container. Is it like that?
Snapshot.
Is it
Snapshot is
related?
not related to the Docker, right?
Okay, is it related to the
Uh,
VM?
Container snapshots. Okay, I have not heard this. word in Docker, this one, or I might have forgotten. I don't remember. What is this? How to take container snapshots in Docker? Oh, okay, okay, okay.
I think it is the
Snapshot is just
ISO
an
image.
image,
Is this
right?
the image? Uh,
Yeah, this will we will come into it. Okay, I think they don't call it as a snapshot. They call it as an image in Docker terms.
okay, okay.
Got it right?
Yeah, yeah, got it, got it, got it.
Hello,
Yes. Hello,
hello.
hello.
Hey, hey,
Am I
I think
audible?
there was a break.
Oh,
You got it right.
Yeah, got it, got it. Now I got it.
Okay, okay. So we call in Docker terms we call it as image. Okay, you can call it as a snapshot also, but yeah, it is actually a snapshot means Docker image.
Hmm.
Yeah, we will discuss that Docker image next.
Sure.
Okay, okay. This is fine. How do I delete this actually? Uh, yeah, I need to learn how to delete this or create a new page.
you can just drag it down, no, the page. Yeah,
Oh
with the
yeah,
hand.
yeah,
Yeah,
yeah. Okay, okay. That is good
that's
actually.
an infinite board. Yeah.
Yeah, yeah, that is good. Good, good. Okay, I am also using this one first time. Okay, this is bit good actually for drawing. Okay, so now, okay, any questions on this? Whatever we discussed now. Anything on any?
No, it is fine till now.
Okay,
Okay.
fine. Then let's discuss this Docker image and all those things. Okay, image creation, management, and registry. Registry we already discussed, but let's recap it also along with this. Um okay, fine. Uh, just give me a second. Oh, just give me a second. Okay, just 1 minute. I'll come. I'll be back.
Sure, sure, sure.
Yeah, just. Okay, so we cannot use this. Okay, I cannot use this. Oh, I'm on the mobile network, so I cannot use my other machine. That's fine. So let's discuss Docker things. I have installed Docker here, I guess. Yeah, it is there. Okay. Um, okay, now you guys talked about the snapshots, right? That's called a Docker image in the Docker terms or the container terms. So, do you know anything about Docker image? Hello.
Yeah, yeah, yeah. We can hear you.
Yeah.
Okay.
So is it like say what my basic idea is like that day only I told you whenever someone is developing something as a developer,
Yeah.
see he will have to install so many dependencies into his machine.
Right.
Maybe
Right.
the
Right.
Java runtime, etc., etc., everything whenever he is developing an app. And maybe that same environment has to be created in the testing and the production also.
Mm-hmm.
So like there will be clash between the developer and the tester maybe sometimes. So
Yes,
what if I can containerize the same image from the developer's part and give it to the tester so that he does not have any problem? So I think that can be
right.
done using Docker.
Oh, that's exactly correct actually. Okay, so
Because earlier there were so many problems because some people will be telling this is not working, that is not working. Even I, as a
correct.
automation tester, I have faced this. Someone will be using
Yeah,
JVM 17.1, someone using JDK this, JDK that, and there is
yeah,
no compatibility actually.
yeah. So okay, let's say that developer creates one container. Okay, so so developer creates one container. uh, Container will show with usually with the circle. So he created one container, and he added maybe he installed multiple applications on that. Okay, and he also added his code into that, and he is now running this container on his machine. Okay, he's running his container on his development machine. Now he has to give this container to the QA for testing. So how do you do that? This container is running on his machine actually. So he can't just like that take and give, right? It's a running instance.
Hmm.
Okay. So what he can do is that he can snapshot it, exactly that word, right? Snapshot.
So ultimately creating an image, I guess, right?
Right. When you take the snapshot of this, right, the image will be created. Okay.
Okay.
So that image he can give it to the QA.
So it will have everything, but just I am curious about like how will it have everything inside that?
It will have um, it will have everything except the kernel related items.
Exactly.
Okay.
The
So
application layer things will be there in that, right? You're talking
yes,
about that.
application,
Okay.
yes, whatever he has installed, right? Like
Uh-huh.
he installed one item, two items, three
Uh,
items, he added his own code.
mm,
All those things will be there. Okay.
mm.
All those things will be snapshotted. So this snapshot usually will be containing of a few MBs. Okay.
Okay, okay.
That I guess we can even check here. Docker Hub, right?
I think
Okay, this
last
image
time
is
you
there.
did it for Ubuntu, I guess. Ubuntu or something.
Yeah, some anything actually. Ubuntu is actually this one, right? Yeah, AI. Maybe you can check Nginx. That might be the real application, right?
Uh-huh.
So what is this? 1 byte plus? Oh, sorry, that is 1 billion downloads actually.
Okay.
Somewhere we should be able to see the size actually. Okay, I don't know whether they're specifying it here. Okay, I thought they might be specifying it here.
So when you pull it, does it not show you the size?
Oh, it will show. It will show.
Uh-huh.
Okay, see, it is.
5 MB
No,
approximately.
yeah, that is Alpine Linux.
Uh-huh.
Alpine Linux is one more that lighter Linux version, right? So
Okay.
that is only 5 MB. Okay, but
That's all.
your yeah, that's all. But it can go up to like maybe 100 MBs
Okay, okay,
also.
okay.
Yeah, sometimes you can go up to like 300 MBs and all. Okay, it
Okay,
depends.
so
It
ultimately
also,
it is still very lightweight only.
yeah,
Mhm.
yes. So it will be smaller. It is easier to share it with the other guys. Okay.
Uh-huh.
So now let's see how do we create the containers. Uh, okay, I think I needed the other machine to show that to you guys, but guess I think. Okay, so I think I have to connect back to the other network, but let me discuss the concepts. Okay, maybe next class we can try it hands on.
Sure, sure, no problem. And Pranab, you will be taking the class on Thursday evening, is it? I just wanted to know because based on that only we will fix our schedule. Hello?
Oh, yeah, you were asking me. Sorry, my name is Pavan. I thought
No,
somebody
sorry, 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 not
Pranav. You
Pranav,
said
sorry,
right?
not Pavan, Pavan,
Oh,
sorry.
okay. I thought there is somebody called Pranav.
No,
Okay,
no, no,
sorry. Yeah,
sorry, sorry.
yeah,
Even my
yeah.
mistake. So what I'm saying is, Thursday you will be taking this, right? Taking our class, is it?
Yes, yes, sir. Thursday we can take it. Okay. Uh, actually saying now I have time. Okay, I can take on the daytime also. Uh, this week. So maybe whenever you guys are there, right? Anytime we can take Monday also. Monday also we can take one class. Yeah, maybe two class per week on weekdays. Okay, max. Then maybe on two class on the weekends we can do. Okay. So Monday also we can take if you want, okay. Or if you
Oh,
want break, then maybe Tuesday also we can take. No, no problem.
yeah,
Okay.
we will let you know about our availability because even we guys have to go to colleges for training
Colleges,
actually.
yeah,
Yeah,
yeah.
that is the main problem.
Uh-huh. Okay. Okay. Yeah, yeah, that is fine. That is fine. Whenever you guys are available. So
Because we all are
if
in the same
I'm
group
also,
only, we will just ping you, and
yeah,
if you are available, then we can take up the class on that particular
yeah,
day.
sure. Yeah, we can do that.
Sure.
Yeah, yeah, we'll do that. Yeah. Okay. So, okay, what I was saying. Uh, yeah, Docker images, right? Okay, so so you okay, you guys have not tried this Docker commands, right?
Not yet, not yet.
let, let me just, I'll not run and show the commands now. I'll show it in the next this one, but I'll just give the normal overview of it. So um, so Docker images ls, if you do this right, you can see whatever Docker images available on the system. Okay, so okay, there is a problem, it's not running. Okay, I am not running any Docker desktop and all in this uh, okay, I cannot show you, okay, for now. So Docker images will be listed. Okay, when you say Docker images ls, Docker images will be listed. Then you can run that one of the image. Let's say Docker images ls listed Ubuntu image. Okay, then you can run this Docker images using the Docker run command. Okay, Docker run minus dt Ubuntu. If you run, it will run the Docker image. It will run the container from this image. It will create a new container. Okay, then you can say Docker ps. So it will list the containers. Okay, so it will list maybe Ubuntu container one, like that, something like that. Okay, some random names it will show. And it will show the running container. This is the actual container. This is the image. It is the blueprint. Okay, it's like a blueprint, and this is the real running instance of that image. Okay,
Mm,
you're getting it right.
yeah.
Yes, yes, yes.
Okay, otherwise give me just a second, I'll revert back, okay, to the other Wi-Fi, and I'll try to connect and show. That might be easier to understand, right?
Yeah, sure, no problem.
Okay, I'll take another 10 minutes. Okay.
No problem, no problem. It's okay.
Okay. Hello.
Yes.
Okay, fine. Yeah, so this is my virtual machine. I also have this. uh, UI to it. Okay, it will come. Yeah, this is my. Okay, my daughter has logged in. I need to change it. Anyway, that's not required for now. So here I have installed the Docker. Okay, uh, you can say Docker version. You see this client is there, server is there, container ID is there, runs is there, all these things are there. Okay, so now I'll do Docker images. That's it. Yeah, sorry, I said Docker images ls here. That's not correct. Docker images. So you see that I have these many images in my system, okay, which was downloaded previously.
Mm.
Okay, so you see here this one, right? This is the registry. Okay, this is the repository. This image is in this Amazon registry and in this repository. You see one more image Ubuntu. This doesn't have any registry or repository. I mean, this is a repository, but it is not any registry is mentioned along with it. This is the default. This is coming from the default registry. Default registry is this one only, Docker hub.docker.com.
Mm.
Okay, so this image I have pulled it from this registry only. Okay, if you
Okay.
don't specify any registry, right, it will be connecting to the default registry, dockerhub.com. Okay, now
Mm.
I have the Ubuntu registry. How do I run it? I say Docker run minus dt. I'll talk about all these things later. What is the switches and all. So I'll run this Docker run minus dt. So now my container is running, and it has generated the UUID for that container, like 148b. Okay. So now how do you check your container is running? You just do the Docker ps. Okay, you see this 148, all those things, right? It's a container ID. So it is created from the image Ubuntu 14 seconds ago. Okay, and its default command, whatever it is running inside, is bin bash. I'll explain that later again. Now, how do you know that this image is running? It's the container is running now. How do you go inside the container? Okay, you can run this docker exec minus it command with this 148b, or you can give it fully also. You can give this also. You can give like this also, and you have to say what command to run. Okay, you have to say bash. Okay, so you will get the bash terminal here. So now you are inside the container. You are not inside the machine, you are inside the container now. Any questions, stop me and ask me. Okay.
Mm, okay.
No, whenever
Okay,
we are
now,
doing it practically, then we'll understand better about this, I guess. Okay.
yeah, yeah, true, true,
Uh,
but I'm just showing you.
yeah, sure,
So
sure, sure. Right now, we're just following what you are saying. That's all.
yeah, yeah, sure. No, but you can still stop me and ask me if you want me
No,
to
sure, sure,
repeat
sure.
something, right?
Yeah.
You can ask me. So you see, I'm inside the container now. Just typed host name. It is showing this one. Now, if I come back, if I type host name, I'm inside my system. But if I go inside the container, I'll type host name. It is this one. Okay, so I'm inside the container now. Okay,
Uh-huh.
and this container doesn't do anything by itself. Okay, it is an operating system container, Ubuntu container. It is not any application what we developed.
Mm-hmm.
So by default it doesn't do anything, but you can create a container, you can go inside it, you can do whatever you want, you can add a code here. Okay, let's say I will create one shell script here. Okay, test dot shell script here. Something. Okay, vi command is not there, but let's say I am just typing echo Pavan into some shell script. Okay, what, cat is also not there. Oh, sorry. What happened? Cat no search file. Oh, sorry, my bad. Uh, yeah. So now this test sh is containing echo. If I run this, okay, permission denied. It is saying, yeah, see, it is running the code, right? It printed my name. I just gave the echo Pavan. Okay, so it is printing Pavan. Okay, just a very, very simple shell script. Okay, so I can do anything inside the container. Okay, I can go. This is a OS container, so I can go inside the container. I can put my code and I can keep it. Okay, now I have created this container. I have changed something. I have added my code. Okay, hello.
Yeah, 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 we can hear you.
Okay.
Mhm.
So now you see, where is my code?
It
Test.sh,
is
where is
there,
code?
the green color
it
one.
is, it is there, right? So now it is there, right? So now docker ps. Okay, so now let's say that I will stop this container. Okay, I will say stop 148b. Okay, I'll stop this container. Okay, and you can again start this container 148b. Immediately it came up. I'll get into that again and go here. I can see it is there. Okay, file is there. Okay, fine, right?
Yeah, 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 exactly.
Okay, I just stopped and started the container. Okay, nothing I did. Okay, nothing I did. I just stopped the container and started the container. You can stop. It's like rebooting stopping the VM and starting the VM, right?
Yeah.
It is very fast in the case of container. Okay, so you can see this test file, right? So now you can, when the container comes up, like when you say start docker start 148b, you can make the container to run this script. Okay, this is my application script, let's say. So
Hmm.
then you can make this test to start this script. Okay,
So you were saying that like it will take a fraction of second to do it. That's what you were trying to tell, I guess.
no, no. What I'm trying to say is that currently it is an operating system image. Okay, by default it runs the bash bash this one terminal. Okay, so whenever I will show you that, maybe I think that is easier to show. Uh, Ubuntu, Ubuntu. Do we have the Docker file here? Docker file here? No. Okay, let's. Okay, and let me go to. Okay, so okay, no, I think I don't want to do that now. So, okay, at least you understood that we can start and stop the Docker, right? And you see the changes whatever I made, it still remained after rebooting the container. Okay, that part is clear, right?
Yeah.
Okay,
So for
So
that you did not have to do anything, right? Like it was automatically saved after you have executed that script.
yes, it is automatically saved because I didn't do anything. I did not kill this container. I just
Uh-huh.
stopped and started the container. Okay,
Okay, okay,
but
okay.
this change will not be, it will not be saved if I completely remove this container. Let's say that I am going to stop this container 1488B, then I will say RM 148B. RM means RM means it will
Remove that
completely
container.
remove the
Okay.
container. Okay, now you say Docker PS, there are no running containers. When you
Uh-huh.
say Docker PS minus EA, you see that my container is there, but it says exited 7 seconds ago. So
Mm-hmm.
I have stopped it. Okay, I have stopped it. I mean, created 8 minutes ago, 7 seconds ago, I have stopped it.
Uh-huh.
Now I say Docker RM148B. 148B. This will completely remove that container. Okay. And my changes, whatever I made, and the container,
It has gone.
everything is, yeah, you
Okay.
cannot bring it back. Now, what you can do is that you can again run the container from the original Docker image. Docker images, that is there, right? Docker images. So now you can run that and create a new container.
Mm-hmm.
So you created again one more container from the same image, exactly same, but my changes are not there. Test.sh is not there
Uh-huh.
because that was inside the old container. Okay.
Now I have a question here. Like,
Yeah.
can we use the same image to create multiple containers?
Which is same image? This one, Ubuntu.
This
Yes, you
Ubuntu
can.
image I'm taking. You can create
Yes, yes,
multiple containers also, multiple images also.
yes,
Okay.
yes.
Uh,
So you just give minus name. I think I forgot. Okay. Uh, you don't even need to give the name. If you want to give the name, you can give the name. Otherwise, you just run one more time. Run one more time. Now there should be three containers running. So you see three containers running. So
uh,
you can give your own name actually, but otherwise it will create its own name.
okay. And they
It
are
will,
independent of each other.
they are completely independent
Exactly.
of each other.
But
They
they
are
are
like
using the
three.
only the host kernel. That's all. Nothing else.
They are only using the host kernel. They are completely independent of each other. They are, it is like they are three separate OS running. Okay, now.
Uh,
Okay, now now you saw that my test.sh is did not that's lost, right?
yeah.
So now if I want to let me stop, let me remove these two containers. Okay, these two containers, let me remove it. So those two containers are removed, only one container is there. Now exec docker exec minus it, this container, I'll go inside. No, I have to give what I need to run actually. Okay, so yeah, so I went inside. Now I'll say that I will echo some one to some file. Okay, test dot txt, something like that. So I have created one text of txt file here. Okay,
Mm,
so now I want to save this. I don't want to lose this. This is my application. So
mhm,
just think that this is the code I have written inside this file.
mhm.
Now I need to pass this as a whole image to the developer. Okay,
Okay.
and this is the full code, and now this code runs inside this operating system. Let's assume that I'm not, I mean, this is just an empty file, but just assume that this is my code.
Yeah.
Okay, I'm a developer. I have written my code. Now I need to send this whole package. Okay, and my test.txt runs on ubuntu image, and I need to give it as a whole package to the
Okay. That particular
tester.
container you want to give it to the tester.
Yes, that particular container I want to give it to the tester. How do I do it? I need to do a commit. I need to do the commit.
Mhm.
Okay. For that, I have to run this commit command. Options I have forgotten. Okay, actually, I'm not using these things frequently. So I need to give the commit, and I have to give the repository name also. If I want, I can give my repository, this one, and I can create a new repo called, sorry, this is a registry. This is a registry, and I can create my new repo called my repo, something like that, or my app, something like that, and I can even tag it, okay, if I want.
That version
Okay,
number you are giving.
yes.
So these
So
commands
now
are
you see,
similar to GitHub actually. Some commands.
yes,
Uh-huh.
yes. Now you see, I committed the changes on top of Ubuntu. So
Hmm.
now if you go and see, if you go and see Docker images, there is a new image.
Hmm.
Okay, what is this new image?
My
It is
app, your application,
just yeah, it is just Ubuntu image
your code.
uh, with my code. That is text.txt.
Hmm.
Okay, only that is extra. Okay, so now this is, let's say I have put my code and on top of Ubuntu, and I have committed this image, and now I can actually push this. I can using the Docker push command, I can push this to this repository, this registry, and this repository, and from there the QA guy can
They can pull
download it
it.
and
Okay.
pull it, and he can do the Docker pull from there. He can do the Docker pull from there, and giving that a name, this full name,
Uh-huh.
and he can download it and he can run it.
Okay,
Okay,
okay, okay.
got it right.
Yeah.
Okay, it's become so simple actually.
Hmm. So you have created an application, you just pushed it to the registry, and that registry you were passing it on to the testing team.
Correct.
Uh-huh.
No, no, that registry is like a normal your GitHub registry, GitHub
Uh,
repo will be there,
Repo
no,
only.
like that.
It is like a repo
Yeah,
only. Okay.
yeah. You just give the link to that repo. I'll just say that okay, uh, 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 this is my application. You just go and download it from here. You
And
just
like
have
it
to
will
be
have everything, right? Every dependency that you are having in your operating system.
yes,
Okay.
whatever I have kept it here. Like I
Uh,
kept my code text.txt and Ubuntu
hmm,
on top of Ubuntu, right? I created.
hmm,
So Ubuntu will be there, and also my text.txt code will be there. Suppose I have added any libraries in along with the text.txt. Maybe I have installed Python, I have installed Java, I have installed some other libraries and all, right? All those things will be there.
okay.
All those things will come as it is, as a snapshot. It will
So that
it
testing team does not have the burden of downloading, installing everything again and again. They
nothing,
can directly
nothing.
start testing the application.
Yeah,
Okay.
yes. So it's seamless actually.
Hmm.
Yeah. So you understood little bit about these things, right?
Yeah, at
So
least we
I
have to get used to the commands gradually, but we
Yeah,
understood the process, the
we need to
flow
try
actually.
practice this. Hmm.
yeah, yeah, sure. So maybe next next class, right?
Uh,
Uh, I will actually do this uh, Docker build and create how to create the image and all. I'll tell you. Okay. One way is to create the image using this Docker commit. Okay,
mhm.
that I already showed you. So I created this image, right? There is other way actually. There is a better way how to create the image. Okay, that we will learn, and once we learn that, then we start doing these commands. Okay, so you guys just try to create the VM and be ready. Okay, so anyways, one of you have already done that, right?
Yes.
Saurav, you have
Yeah,
already
yeah,
done that.
I've already done that.
So if possible, Ashank, you also try to
Yeah,
create one VM, okay?
Mhm.
yeah.
Ubuntu.
I have just created a VM and Ubuntu. I've just installed it. I've done it.
Ah, then it's good enough, okay? Then we will install the Docker and uh,
Yeah, we can
uh,
do that now next.
yeah,
Yep.
we can do that
In
next.
that virtual machine, we
So
can install Ubuntu now, right? Sorry, we can install Docker now, I guess.
yes, yes,
Yes.
yes.
Mhm.
So I
We
have
can
right
install.
now like a VM and I have installed Ubuntu inside that also. So it's ready. Like 4 GB is I've what I've given right now.
Oh, that is enough. Good enough.
Okay.
Yeah. So okay, I'll stop it here now today. Okay.
Okay.
So we'll take it up tomorrow if you guys are available. We can take it up. If not,
Tomorrow, yeah, we can discuss about the same in the group. And
Group,
I
yeah.
think by
yeah.
Tanmay will be coming in sometime, then he will also let you know.
Okay, sure. Is it
Yeah.
possible tomorrow around maybe 10:30 morning, 10:30 to maybe 12 like that, 10:30 or
Yeah,
maybe?
yeah, no problem, no problem. That's okay.
Okay,
Yeah, we can
fine,
discuss
right?
about, yeah. Yep, yeah.
Okay, 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 okay. Then yeah, thanks, guys. Any questions? You just post me in the WhatsApp. Okay.
Definitely,
Yes.
definitely.
Uh,
We have to do
yeah,
our research, then we'll get up lots of questions actually.
sure, sure.
Mm.
Okay, okay, guys. Then
Yeah, sure. Thank you
Okay.
for your time,
Yeah, yeah.
Pavan. Okay.
Thank you. Yeah.
yeah, thanks. Yeah, let's meet tomorrow then.
Sure, sure,
Tomorrow.
sure. Okay.
Okay, then yeah,
Yeah.
bye.
Bye.
Okay. Bye.